In this lecture, we're going to be going over variable declarations in Java, the various built-in types, and scoping of variables in Java. The notes can be found in the Java Basics part of the online notes. So variable declarations in Java are identical to the way they're done in C++. So here you can see you're allowed to declare a variable, assign a value to it. The big difference between Java and C++ comes in Java's more restrictive way of declaring variables inside of blocks. So in C++, this code that you see right here contains two definitions of J, one at the function level, a second embedded within the loop. And in C++, this is a fine declaration or redeclaration of J. Inside the loop declarations of J supersedes the function's definition of J. However, in Java, this second declaration of J is illegal. Java allows only one declaration of a variable to be active at any one time. And since at the point where I declare J right here, this J is active, Java is upset. So here I have actually created the function for countPositive and embedded it in a class foo, and I'm going to compile it to show you the error message you get. And you can see it says J is already defined in countPositive. Now, that rule does not say that you cannot use or declare a variable multiple times. Here I've declared I twice, once each in two different loops. The reason that it is valid to declare I here is that there is no other active declaration for I currently in place. If I instead had declared I at the function level, neither of these two loop variables would have passed the Java compiler test. Also, you should know that once a variable goes out of scope, it is undefined and you can no longer access its value. This is the same as what happens in C++. Java has the same built-in types essentially as C++. The one difference is that the Boolean must now be spelled out rather than abbreviated as bool as done in C++. As you can see, it also has 4 different kinds of integer values depending on how many bits you need, and 2 different lengths for its floating point values. Java is a little bit different in how it does its type conversions than C++. In fact, it is more strict. So like C++, it's okay when it's doing a type conversion that involves no loss of precision. So here I have a double B and an int a, and Java is more than happy to allow me to assign the integer a to the double B because there's no loss of precision. However, if I try to reverse it and assign B to A, there is a loss of precision. If B was 3.5, all I can store in A is 3. And Java actually will generate an error message in this situation. C++ will generate a warning message, and actually some versions of the C compiler will not even generate a warning message in this case. You can still perform the assignment in Java, but you have to explicitly downcast or narrow the value. So in this case, I am converting B to an int and then assigning it to A, and now the compiler is fine with it. So you should be comfortable with this word narrowing, which means to decrease the precision of a type. Before you downcast, you may want to check to see that you actually have the correct type of object, because if you try to downcast to an invalid object, Java will throw an exception. If you remember, you can't, for example, try to downcast a list class to an integer. It just won't work in Java. So it provides an instance of operator that allows you to check to see whether a variable is actually an instance of a certain type before you do the downcast. And you'll see that the operator returns true if the type is either the object's type or it is a superclass of the object's type. So for example, if I had stack, and it's always an instance of an object, so even if B was a stack, if I said B is an instance of object, it would be okay with that. And you're always allowed to cast a subclass to the superclass because it doesn't entail, in some sense, a loss of precision. You still have the same methods available. However, if you try to downcast, say, an object to a stack, that could cause an error if the object were not a stack, because that involves a loss of precision. You're actually assigning to something that has more restrictions on it.